Good morning. This is question number 9. A balanced delta connected 3-phase load draws 200 ampere. The phase with a leading power factor of 0.85 from a 12.47 kilovolt line to line system. Determine the line current magnitude of the load. These are the 6 questions. Line current magnitude of the load, phase voltage magnitude of the load, total apparent power of the load, total real power drawn by the load, total reactive power drawn by the load, total complex power drawn by the load. Okay, so coming to first question, the line current magnitude of the load. So delta connected load, line voltage equals phase voltage and line current equals root 3 phase current. So phase current is given as 200, so line current will be root 2 multiplied by phase current. It will give 346.4 ampere. In the same way, line voltage equals phase voltage. So line voltage is given as 12.747 kilovolt. So phase voltage will be same. Coming to question number C. Question number, total apparent power of the load. Total apparent power of the load is given by ST equals root 3 line voltage, line current multiplied by line current, or 3 phase voltage into phase current. Either this you can use or this. Substitute here line voltage and line current. You will get the value as 7482 kilovolt ampere. Active power formula is PT equals root 3 VL cos phi. So phi is given as, cos phi is given as 0.85. Substitute VL and cos phi is given as power factor 0.85. You will get PT, that is active power, equals 6359.5 kilowatt. In the same way, reactive power, the formula is Q equals root 3 VL sin phi. You can substitute VL, okay, but sin phi, cos phi is given as 0.85 in the question, power factor, and phi will be 31.79 degrees. Substitute in sin 31.79. The value will be, by using the calculator, you will get the value of sin phi 346.4. Substitute all these values, you will get 3941 kilovolt ampere R. Okay, volt ampere resistance. Complex power. What is the formula of complex power? ST equals root 3 VL bar IL bar star. Okay, so what is IL bar here? 346.4 to the angle 31.79 degrees. Okay, and VL bar is given as 12.47 0 degrees kilovolt. As you substitute here, ST bar equals root 3, substitute here, you will get this value. Okay, 6359.5 minus G 3941 kilovolt ampere. Okay, now coming to question number 10. Refer to the unbalanced circuit. Calculate the line currents, real power absorbed by the load, complex power supplied by the source. So this is unbalanced circuit. Here it is J10 20 ohm minus J5 ohm. This is unbalanced circuit, and the voltages are given here. So from mesh 1, there are 3 mesh here, I1, I2, I3. Coming to mesh 1, you will get the equation as 440 to the angle minus 120 degrees, this one, and minus 440 to the angle 0, this here it is minus, and coming to here plus j 10 multiplied by I1 minus I3. I1 is this current, and I3 is in the opposite direction, so minus I3. After you simplify, you will get I1. From this equation you will get I1 minus I3 equals 76.21 to the angle minus 60 degrees. This is equation 1. From mesh 2, you can see here, from mesh 2 you can write here 440 to the angle 120 degrees minus 440 to the angle minus 120 degrees and 20 multiplied by I2 minus I3. This is equation mesh equation for mesh 2. Now simplify this, you will get I3 minus I2 equals I38.105. This is equation 2. Coming to mesh 3. Mesh 3, this is mesh 3. J10 multiplied by I3 minus I1 minus J5 multiplied by I3 plus 20 multiplied by I3 minus I2. This is equation 3 for mesh 3. This one. Now substitute equation 1 and equation 2 in equation 3. We have in equation 3 I3 minus I1, I3 minus I2. You can see here. Here we have I3 minus I2. This we can substitute here in equation 3. And in the place I3 minus I1, here we have I1 minus I3. So you will be writing here negative sign. In the place I3 minus I1, negative. You can see here. Minus here. Okay. Now after simplification you will get the value I3 equals 80.4 in rectangular form, 80.4 plus j 124.7. Okay, and in polar form 148.37 to the angle 57.2 degrees. Then what is the value of I1 by using the same formula? Equation 1. Equation 1, from equation 1 you will get I1 equals this, I3 on the right hand side. You will get the value of I1 as 132.23 to the angle 26.36 degrees. In the same way, by using equation 2 you will get value of I2 equals this. Substitute I3, you will get in polar form I2 value will be 118.16 to the angle 47.14 degrees. Now by using this I1, I2, I3 we will be finding line currents IA, IB, IC. What is IA? By the equation, by the diagram, circuit diagram, you can check here. What is IA? IA is same as I1, so the value of IA will be same as I1. And what is IB? IB will be I2 minus I1. IB is in this direction, from left to right direction, so I2 is in the same direction of IB. IB will be I2 minus I1. You can see the solution. In the same way, what is I3 here? I3 will be I3 is in this direction, this one. So sorry, IC, we need IC, not I3. Okay, sorry. So IC, where is IC here? This is IC. So IC will be, you can check here, you can check here, IA is this in this direction, IA in this direction, IB in this direction, IC in this direction. So IC will be minus of IA minus IB. If you see here, IC will be minus of IA minus of IB. This is IC. This is the last line current. IC is, yeah, you can use IAIB, or you can use I2. What is I2 here? IC. Yeah, here we have I2 directly. I2 is the same value of IC but in the opposite direction, so IC will be minus I2. That's it. So we finish this sheet.